Welcome back everyone, Patrick here, and in this next question we have to show that the triangle with these vertices -1 and 7, 10, -4, and then 12, -2 is a right triangle, and then we have to find its area. So remember, a right triangle, what that means is that one of the angles is 90 degrees. And the way that we could show that a triangle, given its vertices, is a right angle triangle is if two of the sides have slopes that are perpendicular to each other, which means they are negative reciprocals of each other. So that's what we're going to have to do. We're going to have to find the slope of each of these sides, and then if two of them are negative reciprocals, then we know that between those lines is going to be 90 degrees, and that would make it a right triangle. So let's draw a quick diagram of what's going on here. So we have -1 and 7, which would be like up here. So let's actually label these. This will be A, B, C. So we'll have A at -1 and 7. Then we'll have B at 10 and -4. That would be like down here. And then we'll have C at 12 and -2. So that would be, if over here is 10, 12 would be like here. That would be C right there, 12 and -2. Just a rough drawing. And so if we connect all of these, we end up getting something like that. So just from the diagram, you can have sort of prediction of which of the lines are going to be perpendicular to each other. It's probably going to be AB and BC, like the right angle is probably going to be there, but you're never quite sure unless you do it on graphing paper. Then you can know for sure which one is going to have the right angle. But if you're making a rough drawing, sometimes it's hard to tell, but I'm going to predict that it's going to be these two lines over here. And actually that might save you time. So instead of finding all the slopes, if the first two slopes that you find are negative reciprocals of each other, then you know it's going to be a right angle triangle. So let's start off with that. Let's find the slope between, or of the line AB. So remember, what is the slope formula? Well, it's y2 minus y1 over x2 minus x1. Rise over run. So -1 and 7, let's write out these points here, and then we have 10 and -4. So we'll let this be x1, y1, x2, y2. Again, it doesn't matter which ones you label x1, y1, x2, y2. You'll still end up with the same slope. So we'll have y2 minus y1, so we'll have -4 minus 7 all over x2, 10 minus -1, like that. And this -1 has to go in brackets. So we'd end up with -11, and then over here we'll have 10 minus -1, which is like 10 plus 1, which would give us +11, which would give us -1. Right, so the AB slope, or let's actually, I'll write it over here. So the slope of AB is equal to -1. Now let's find the slope, or actually I'm going to keep this general formula. Let's find the slope. So step 2 is going to be finding the slope of BC, right, of this line over here. And so the 2 points we're going to work with is the B point, which is 10 and -4, and then 12 and -2. So following the exact same steps, so we'll have x1, y1, we'll have x2, y2. So we'd have y2 minus y1, so we'll have -2 minus -4 over x2, which is 12, minus x1, which is 10. So over here, we'd end up with -2 plus 4, right? These two negatives make a positive. 12 minus 10 is 2. And then we'll have -2 plus 4, which is +2, over positive 2, which gives us 1. And notice that this slope and this slope are indeed negative reciprocals of each other. Okay, and if they weren't, then we would find the slope of this line AC, and then hopefully that line would be a negative reciprocal of one of these slopes. But our prediction was correct that the right angle is going to be right there. So we actually don't even need to find the slope of AC, but your teacher may require you to find all 3 slopes. So if so, make sure you do. But if the first 2 slopes you find are negative reciprocals of each other, then you know that it's a right angle triangle. So because of this over here, we showed that it's a right angle. And just in case you're confused how 1 and -1 are negative reciprocals of each other, well, -1, that's like over 1. And so what's the reciprocal of that? Well, it would be 1 over -1, but then you also have to change the sign, right? A negative reciprocal. So this would end up being positive, right? So this is -1, this is +1. -1 and +1 are always negative reciprocals of one another. All right, so from there, we could tell that it's a right angle triangle. That's how you show it. You find the slopes, and then if 2 of the slopes are negative reciprocals, then you know there's a right angle there. Now, we also have to find the area. So remember, the area of a triangle is what? It's base times height divided by 2. And with a right triangle, it's actually fairly easy, because if we have a right triangle, well, the base is just going to be one of the sides, and then the height is going to be one of the sides. It's going to be both sides that are attached to that 90 degrees. If you don't have a right angle triangle, then it's a little bit more complex. It's a little tougher to find the area because you can get the base from one of the sides, but then you're going to have to find the altitude from that opposite vertex first, and then you're going to have to find the length of that altitude, and then from there you could find the area. But with a right triangle specifically, it's really easy because the base and the height are given. So we can use either this as the base and then this as the height, or we could use this as the base and then that as the height, right? We don't have to find an altitude or like an extra line to work with. So what we got to do though is we got to find the length of the base. I'm going to let the base be AB in this case, and then I'm going to let the height of the triangle be BC. Again, it doesn't matter which one because you're just going to be multiplying there anyway. You're going to get the same answer. But for reference, that's what I'm going to do. And so now what we got to do is find the length of AB, the length of BC. So as a review, what is the length formula? Well, it's just the square root of x2 minus x1 to the power 2 plus y2 minus y1 to the power of 2. So let's start off with finding the length of AB. So what we would do is the 2 points we're going to use, let's write them out over here. So we'll let this be x1, y1, x2, y2. And then we'll have, let's just plug everything in. So we'll have x2, which is 10, minus x1, which is -1. That's going to be squared, plus y2, which is -4, minus y1, which is 7. And then that's going to be squared as well. So what we would end up with here is, notice we have 10 minus -1, which is like 10 plus 1. So that would end up being 11 in the brackets. Over here, we'd end up with -11. Now, 11 to the power 2 is 121. And then -11 to the power 2 is 121 as well. And so adding these up, we would end up with 242. So the square root of 242. So that's going to be the length of AB. So I'll write this over here. So our base You can also get the decimals if you want. I'm going to keep it as exact values for now. Our base is going to be root 242. That's going to be the length of it. Now what about the height? So the height, we said it's going to be the line BC. So the 2 points we're going to use is the B point again, 10, -4, and then the C point, which is 12, -2. So I'm going to let this be x1, y1, x2, y2 like that. So we'd end up with the square root of x2, which is 12. Again, the order here doesn't matter. You could let this be x2, y2, this x1, y1. You'd still get the same exact solution. Like that, right? x2 minus x1, y2 minus y1. And then both of them are going to be squared. So this would end up being 12 minus 10 is 2. That's going to be to the power 2 plus -2 minus -4 is like -2 plus 4, which is +2. That would be squared. So we'd end up with the square root of 4 plus 4, which would give us root 8. And so the height is going to be the square root of 8. Again, if you want to get the decimals, really easy to get them. You can just plug these into your calculator, but some teachers want you to work with exact values, and it's tougher to work with exact values than to just get the decimals. So I'm going to show you the exact value solution. And then at the end, if you want to convert it to decimals, you can do that as well. But just in case your teacher wants exact values, that's what we'll use. So now that we have those two lengths, we just plug them into the formula. So we'll have the base, which is root 242, and then the height, which is root 8, and then we're going to be dividing that by 2. Now, whenever you're multiplying square roots, so just in general, as a rule here, if you have like the square root of A times the square root of B, well, you could put them both under the square root and just multiply them right there. So that's what I'm going to do here. You could take the 242 multiplied by the 8, and that would actually give you 1,936. That's going to be all over 2. And then if you take the square root of 1,936, it actually gives you a smooth number. It gives you 44. And then that's going to be divided by 2, which would be 22. And so that right there ends up being the area. You might want to write units squared. Right? Area is always in terms of some kind of units squared. There's no units given over here, but your teacher may require you to write that. All right, and that's how you do the question. So to prove it's a right angle, find all the slopes, make sure 2 of the slopes are negative reciprocals of one another. If they are, then you prove that it's a right angle triangle. And then if you have to find the area of a right angle triangle, it's fairly easy because you just have to use the 2 sides that are attached to that 90 degrees, to that right angle, as the base and the height. Doesn't matter which one you use as the base and the height. So just do the algebra, find the lengths of the base and height, plug them into the formula, get your